Hello and welcome back. In this segment we're going to talk about interfaces. And I'm not referring to graphical user interfaces like buttons and text boxes and menus and so on. I'm talking about the application programmer interface, or the API. And interfaces, or an interface in Java, is a mechanism for specifying what methods will appear in a class. It's a little bit too complicated to talk about it in the abstract, so we're going to start by reviewing what we did in the last one about abstract methods, and then abstract classes and methods, and then we'll use that to ease into how interfaces are provided as a mechanism in Java. So remember that abstract classes. An abstract class is a class that has one or more abstract methods. And you can't make an instance of an abstract class, but abstract classes still have data and methods, concrete methods, constructor methods, toString methods, and so on. So an abstract class could be one that is a normal looking class that has one method in it that's not defined. You'll recall that abstract classes impose something on the subclasses. What they impose is that the subclasses provide an implementation of the methods that are abstract. So the abstract methods are overridden in the subclass with a concrete method, a method that has braces and some functionality. So the name of an abstract class is still used as a compile time type. So although you never have an instance of an abstract class, you can have a compile time type. For example, a parameters data type could be the name of an abstract class, and then you can pass in an object which is one of those abstract things. I'm going to say that sentence again. So the name of an abstract class can still be used as a compile time type, even though you can't make an instance of an abstract class. You can still have, for example, a method that has a parameters data type, which is the name of an abstract class, and you can pass in something that is one of those things. So the example that we looked at was animal was the name of the parameter type, and you could pass in a dog or a cat, because a dog or a cat is a animal. Okay, let's springboard from there into the interface mechanism. So interfaces, there are some similarities to abstract classes. An interface is something that looks kind of like a class, except it has only abstract method signatures in it. And a class then would agree to implement that interface, and that would mean to provide an implementation for those abstract method signatures. When a class agrees to implement an interface, that class must override the abstract method signatures that are defined in the interface. Let's go and make one and then come back and look at these points again, because I think it will only make sense to you if you see one happening. Okay, what I want to do first is, now we're in the same project that we had looked at before. We made the animal class an abstract class, and we had this abstract method makeNoise, which imposes on all of the subclasses of animal that they would implement this abstract method. Okay, so what I'm going to do is I'm going to change this code, and instead of having this abstract method here and an abstract animal class, I'm going to define this abstract method in an interface. Okay, let's go into our project and say new, and this time instead of class we're going to say interface. And I'm going to say I'm going to make an interface called noisy. Now this looks like the definition of a class, and you might notice that it starts with a capital letter. So this is the only thing other than a class that can start with a capital letter in Java. And an interface, so it looks like it's the same as public class noisy, except this one is, the keyword is interface instead of class. And it is in a .java file, and it compiles the same as a class would in a .java file into a .class file. So here's what I'm going to do. I'm going to make a public abstract method signature, and I'm going to make it a void make noise with no parameters. And in an interface, all of the methods are public and abstract. In fact, you don't have to include those words. So if you do or don't, it doesn't make any difference. Whoops. You cannot make them private. That wouldn't make sense. So public, private, or protected, the only thing that makes sense here is public. That's all that will compile. Okay, so this is a very simple interface, and a lot of interfaces really are simple. They have one public abstract method signature. You can have as many abstract method signatures as you need, but you can't have any functionality, meaning you can't have any concrete methods, no braces on your methods, and you cannot have any instance variables. So you don't ever make an instance of an interface. That's it. That's what you can do in an interface. So now let's go and use it. I'm going to undo this abstract class. So I'm going to say that the animal class is not abstract anymore. But what I am going to say is that the animal class implements noisy. Okay, so here's a new keyword for you, implements, and then a name of an interface. And it doesn't compile yet because the type animal must implement the inherited. Okay, so we agreed to implement the noisy interface, but we haven't done it. So public void make noise with no parameters, and let's put something in here. It doesn't much matter what. So here's what we've done. We have implemented the interface by overriding the methods that were defined, the abstract methods that were defined in the interface. It's really that simple as the mechanism goes, and you're probably sitting there saying, why would we be doing that? Good question. I've made a small test program here so that we can play with this a little bit. So I'm going to make an instance of dog. Well, no, let's start right from the beginning. Let's make an instance of animal. We can do that again because the animal class is not abstract anymore. And if we type pet.makeNoise should pop up, and it does because it is a method that's defined in the animal. and that should probably run and say, I don't make any noise. Good. Okay, what have we gained by using an interface called noisy? I'm going to declare a variable of type noisy. A noisy thing. Okay, it's a reference variable. That means it's going to refer to an object of some type. And the question is, what kind of an object can we assign to this reference variable? How about an animal? Can we do that? Yes, we can. So this is a compile time type only. The name of an interface is used as a compile time type. You never have an instance of an interface. Now let's think about a method that takes an object of that type. A noisy n. Okay, what can you pass to that method? Can you pass a string? No, you cannot, because string is not from a class that implements the noisy interface. Can you pass an animal? Well, yes, you can. Do stuff, pass in pet. And when you're in here, what is available to the object, what is available to you, the programmer, from the object that was passed in? If I say n dot, what pops up? Make noise. Well, how does Eclipse know that the object passed in will have a make noise method? It knows that because anything that can be assigned to a noisy compile time type must have implemented the noisy interface. And that means that the object passed in will have a make noise method. This is not an inheritance relationship. So classes that implement the noisy interface don't have to be related by inheritance. So if we had a car class and the cars make a noise as well, that means they have a make noise method, we could pass cars in here. This is a different type of polymorphism. In our previous example, where we had a method this method takes anything that is an animal, and there is a kind of polymorphism going on here. We could pass an animal or a cat or a dog, anything that is an animal. So here's a method where the type of the parameter is the name of an interface, and we don't know anything about the inheritance of the object that was passed in, but we do know something about the object that was passed in. We know that the object that was passed in has a method make noise. What do we know about the object that was passed in here? We know that it either is an animal object or it inherits from animal, and that means that we know something about those objects as well. We know that they can do anything that an animal can do because they have inherited those things. Okay, let's think about this interface mechanism in Java. Why would you want to do this? Well, it's another way of defining a set of objects. So there are a bunch of objects that have this characteristic. Anything that has implemented the noisy interface is a particular kind of object that can be passed around to methods that have that as the compile time type. Okay, we're going to implement now an interface that already exists. So there's a bunch of interfaces already in the JDK, and we can look at one very simple one. Called comparable. So the comparable interface, you can say comparable if you want to, would allow us to compare objects of type dog to each other. Remember the equals method. This allows us to compare objects of type dog to each other and return true or false. But the comparable interface defines an abstract method signature that requires us to override a method that looks like this. Public int compare to, and you have to spell it right. Compare to, and it takes an object. Well, I think that all dogs are equal, so I'm going to put return 0 just for now. Okay, so this compiles now. The comparable interface has one method signature in it. It's a public abstract int compare to that takes an object, and the objective is anything that's comparable, any class that agrees to implement comparable must have this compare to, and it shouldn't return 0, it should return the difference between the two dog objects. So eventually I want to say dog1 dot compare to dog2, and I want that to evaluate to an integer difference between them. So maybe we could say that the difference between two dogs is the difference between their weight. So we've got this weight. So I'll call get weight, subtract. There's the cast operator. I'm going to downcast obj to be a dog. And then I'm going to call the getWeight method. Okay, so the same thing we had in the equals method. If you want to compare two dog objects, you get to decide which one comes first. There's a relationship between the compare to method and the equals method. If you compare two dogs and they are equal, and then you compare them using the compare to method, the same two objects, the difference between the two dogs should be 0. Does that make sense? If two dogs are equal, their difference is 0. And if their difference is 0, the two dogs are equal. So it's expected that if you implement the comparable interface, you should also make sure that this is in sync with your equals method. If you compared the names of the dogs in your equals method, then your compare to method should also compare the names of the dogs and somehow figure out a way of how to measure the difference between the two names. Well, the string class has a compare to method. There's a hint. Most classes will implement the compare to method when it makes sense that one of the objects would come before the other. The comparable interface is probably the most common one in Java. It has only one method signature in it, and you're pretty much expected to implement that if it's ever going to be interesting that one of the objects comes before the other. So if you have a bunch of these objects and you want to sort them, how would the sorting algorithms know which dog would come before which dog? And in Sun terminology, the compare to method defines the natural ordering of the dog objects, or the natural ordering of whoever implements the comparable interface. I'm not sure why they call it the natural order, because there's nothing natural about this, but that is the expression that they use. Okay, so let's think about what we've done. We've defined one of our own interfaces just to see how this is done, and we implemented that interface in the animal class. Then we looked at one of the interfaces which is available to you in the Java application programmer interface, and we implemented it here in the dog class. You might be noticing that implements and extends are not exclusive of each other. We can extend one class and then we can implement as many interfaces as we want to. So let's go back to test interface and think about how we could use objects that are of type comparable. So I'm going to make a couple of dogs. I'll do that without you having to watch. Just a second. Okay, so here are a couple of dogs, Max and Rover, and we have defined a method compare to in the dog class. So if we say max dot compare to Rover and print out what that returns, let's see what we get here. Minus 20, so Max weighs 20 pounds less than Rover, and if we do it the other way, if we say Rover dot compare to Max, I hope you're guessing that the answer would be 20, and this is one of the rules when you're implementing the comparable interface. It's called a contract. If you compare A to B, then this is the negative value of comparing B to A. And if you compare A to B with equals method and it returns true, then the compare to method should return 0. So think of it as the compare to method determines the difference between the two objects being compared as an integer number, as opposed to the equals method, which decides only if the two objects are equal, true or false. Okay, let's think about a method that could take things that are comparable. Public static Boolean, I'm going to call it bigger. No, even better. So we can say comparable object 1, comparable object 2. So what can we pass to this method better? I'm trying to get to where I can say my dog's better than your dog. I can pass dogs to the better method because they implement the interface comparable. Now, that's not compiling yet because I said I would return a Boolean and I haven't. Now it will compile, but it doesn't really do anything useful to just return true all the time. So I could say if if better, Max Rover my dog's better. So inside better, I'm going to say if object1 dot, and what pops up? There must be a compare to method. Object2, if object1 dot compare to object2 is greater than 0, then I'm going to return true. Else return false. So what can be passed to this method? We can see that we can pass in two dog objects because they are comparable to each other. If we had two strings, could we pass in two strings here? Let's see if that'll compile. It turns out that the string class has implemented the comparable interface as well. So now we're defining methods that can take anything that is comparable one to the other. Might not still sound like you're finding that this is really useful yet. I'm going to make one more method signature and I won't implement this whole thing. I'm going to make a method called sort, and I'm going to pass in an array of comparable. My comparable objects. And you have to spell things right. Okay. Could we sort an array of dogs in here? How do you sort an array of things? Well, you check and see if one comes before the other, and then you swap them if they're not in the right place. So I'm kind of hoping that you've looked at sorting algorithms before, because you're going to have, I'm not going to write this algorithm, you're going to have to kind of imagine that if I had an array of dogs, could I pass an array of dogs in here to be sorted? Yes. How about an array of strings? Well, strings are comparable, so I could pass in an array of strings. And the reason that I'm not going to write the code for this sort algorithm is because you don't have to either. There is already a sort algorithm based on the fact that you can define things that are comparable. So the sort algorithms that exist will call your compare to methods and sort your objects. So if you have an array of race cars, you can sort them if the race car class has implemented the comparable interface. So it should start to feel like this is a useful thing to do. So what kind of objects can you pass in here? It has nothing to do with the inheritance. It has to do with whether the class has implemented the comparable interface. My comparable objects sub-0 dot, and what will pop up? The first one is compare to. So if you're passing in an array of dogs, an array of strings, an array of race cars, there will be a compare to method in the objects that are in the array. And we know that because we're using the name of the interface as the parameter's compile time data type. So let's talk just a minute about what we've learned in this video, the interface mechanism. So the first thing to say is, other than the name of a class, an interface is the only identifier that starts with a capital letter. And the structure of an interface looks similar to the structure of a class. You say public interface and then the name, as opposed to public class and then the name. And an interface will contain only public abstract method signatures. Interfaces are very simple. They don't have any concrete methods, they don't have any data, they don't have any constructors or toStrings. You never make an instance of an interface. But an interface does impose something on the classes. The classes that agree to implement the interface, and they use the implements keyword, those classes must provide an implementation of the abstract method signatures that appear in the interface. And the key to using this is that the name of an interface can be used as a compile time type. So we looked at a case where we would use the noisy data type as a way of defining a method that could take in things that are noisy, and that might be dogs or cars or anything, objects of any class that have agreed to implement the noisy interface. And we looked at the comparable interface, which is one that's defined for you and you're pretty much expected to implement. And the comparable interface, it had only one method signature as well, compare to, and that method is used very commonly throughout Java, because it's such a common thing to define the order of objects. So which dog comes before which dog, which string comes before which string, and so on. This is a different type of polymorphism. It's polymorphism based on what methods will be in the object when we get it, as opposed to the type of polymorphism that we had with inheritance that had to do with the is-a relationship. So if we used a parent class as a compile time type, we know that we would have an object that is one of those things. But with interfaces, when we use the name of an interface as a compile time type, we know that the object has come from a class that implements that interface. So we know something about the object, but we don't know anything about its inheritance or its lineage. We know only something about what methods are going to be in that object, and that's the methods that are defined in the interface. Well, this is an interesting mechanism, and the first time you see it, it takes you a couple of times to really believe that this will be a useful thing to do, but it is. So let's leave this one there, and I'll see you in the next video.